So good morning, everyone, and welcome to this webinar, Biowaste in the EU. What can we learn from EU projects, challenges, solutions, and policy perspectives? I'm Edoardo Nencetti, project manager at ETA Florence, also working in the Bean2Bean project. And this webinar is a joint activity with two other sister projects, bioSOILutions and FENIX. So as you probably saw from the agenda, we will start with an introductory session on biowaste management and the regulatory framework behind the valorization into circular fertilizers and soil improvers. Then we will hear from representatives from the three projects that will present their direct experiences from the field. And we'll then proceed with an interactive session between the speakers. So before to start, just one simple housekeeping rule. For any question that you would like to ask during the session, you can easily use the Q&A box at the top. And after the interactive session, we will try to answer some of those questions. Of course, the webinar will be recorded, so you will be able to find the recording very soon, available on the website of our projects. So nothing to add here. We can already start with our first speaker, which is Aline Gragnard, Policy Officer at the European Compost Network. So Aline, please, you can start sharing your presentation.
Yeah, thank you. So you should be able to see it in presentation mode. Okay, it's okay now? You can see the slides, perfect.
Yes.
And so, yeah, good morning, everyone. And thank you for giving me this opportunity to introduce the topic of this very interesting webinar. So, yeah, as you said, my name is Aline Gragnard, and I'm Policy Officer at ECN, the European Compost Network. And I will give you an overview of the biowaste management at EU level. So I will start by just briefly introducing our organization. So ECN is a membership organization with 67 members from 27 European countries. We represent more than 4,500 composting and anaerobic digestion plants treating separately collected biowaste with a treatment capacity of 48 million tons per year. And our work is divided between quality assurance of compost and digestate, policy work, and also improve market conditions and innovation. So, yeah, first I wanted to stress that biowaste is really what we can call a cross-cutting resource because it can be found in diverse European texts and legislations. And it can be recycled into many different products, from biogas to bio-based products, and of course organic fertilizers. And this way, it can be a substitution to synthetic products or materials. So then, if we have a deeper look at what is biowaste. So we have the legal definition in the Waste Framework Directive. So basically, biowaste encompasses biodegradable garden and park waste, food and kitchen waste from households, offices, restaurants, wholesale, canteens, caterers, and retail premises. And it also encompasses comparable waste from the food processing industry. So as you can see, in the Waste Framework Directive, the EU set different targets for municipal waste in general. So basically, member states, they will have to recycle 65% of their municipal solid waste, and they will have to limit the landfill to 10% by 2035. And as biowaste in the end represents the largest fraction in this municipal solid waste, because it represents around 1/3 of the municipal waste that is generated. So this means that we really need to recycle biowaste to achieve these targets. And this is why the Waste Framework Directive introduced a mandatory separate collection of biowaste. So this obligation is in force since 2024, but it still needs to be implemented in many countries. So to give you an idea, if we just look at kitchen waste, only 26% is currently recycled. Separately collected and then recycled, of course. So the rest that is not separately collected is collected with the residual waste, and it's incinerated or landfilled. More generally, in the Waste Framework Directive, the member states are also required to take measures to encourage the recycling of biowaste, also to encourage home composting, and to promote the use of materials produced from biowaste. Then in terms of, here you go, in terms of treatment of biowaste, so yeah, I can introduce you the different processes from where I stand from the composting sector. So basically, biowaste can be recycled following a composting process, which produces compost, or an anaerobic digestion process, which produces digestate and biogas. But biowaste can also be treated by both processes. And on the other side of the slide, so yeah, it's interesting because you can see the different biowaste that we can use as input, and they differ regarding the treatment, the process that we are using. So, for example, green waste is mainly composting, while food waste more goes to anaerobic digestion because it has a higher energy potential. Now, if we can have a look at what we produce as an output. So after we separately collect and recycle biowaste, we can obtain high quality fertilizing products that we can then apply on soil. So to regulate these fertilizing products, we have the fertilizing products regulation. It's important because it's only in 2019 that the recycled organic fertilizers and soil improvers were included in the fertilizing products regulation alongside mineral fertilizers. And the objective was, of course, to foster the use of these organic products. And it was really an important step forward. The fertilizing products regulation also introduced for the first time an end of waste criteria for compost and digestate. So this means that compost and digestate can be labeled with the CE mark and be placed on the single markets. Although this end of waste is optional, which means that the operators they will decide whether they want to apply the fertilizing products regulation and apply the CE mark on their products or not. So in general, to get the CE mark, the products must fulfill quality requirements. So the producers, they will have to demonstrate that their products comply with environmental and health requirements. For example, they must not exceed limit values for specific contaminants. And in addition, specific criteria also apply for compost and digestate in terms of impurities, of course. So, for example, glass, metals, plastics. And there are also requirements for the process, for the treatment process. So how it should be done, for example, for how long the biowaste should be treated, at which temperature, etc. And then the final fertilizing products can be placed on the market according to a specific conformity assessment procedure. And in the end, the possibility to market organic fertilizing products, it created market opportunities. But it's important to stress that there is also room for improvement because, there are still unsuitable, let's say, regulatory requirements that can hinder market access. But I think we will also talk about this later. And here I just wanted to have a few words on some figures that might be interesting in terms of quantities that is treated and produced. And these figures are come from the ECN data report. You have the link on the slide. So basically, we currently recycle 71 million tons of separately collected biowaste. And from this, we produce 21 million tons of compost. So in other words, this means that with 10 tons of fresh mass compost applied on soil, we can cover 2% of arable land or 16% of arable land that is severely eroded. Because of course compost can improve soil health and has multiple environmental benefits. We also calculated that if we further improve separate collection of biowaste, which is really the big objective, then we could produce by 2035 46 million tons of compost. And so now I will just finish my presentation with by introducing the first EU-funded project of this webinar. So it's the Ferticovery project. So it's a Horizon project, which started in January this year. It's pretty recent, and it will run for 3 years. So its aim it's to analyze best available techniques to recover or recycle fertilizing products from secondary raw materials. Through this project, we will advise policymakers and stakeholders on alternative fertilizing products. And regarding the outcomes, so we will, and we are establishing now actually a description of more than 75 technologies, detailing the type of feedstock, the type of technology, and the type of products. And then we will make an in-depth analysis of 25 of these technologies, focusing on their composition, their applications, and also their environmental impacts. And out of these 25 technologies, we will select and identify the 15 best available technologies, and we will provide detailed fact sheets on them. With all this data and information, we will be able to provide recommendations to policymakers and practitioners. So we are 8 project partners from different countries, as you can see on the slide, and also different backgrounds. So there are consultancies, universities, and European associations. If you want to have more information, you can contact the project coordinator, Martin Vis. You can also have a look at our website. And I also invite you to follow us on LinkedIn. So we have a LinkedIn page, but we also have a dedicated LinkedIn group where we provide a forum for discussion and sharing knowledge and experience on alternative bio-based fertilizers. Yeah. That was
Thank you very much. Thank you very much, Aline, for this good start. Time now to get into the direct experiences of our 3 sister projects. And we will start with the first one, which is bioSOILutions. So we have Cristiano Pisani from SETENMA, Technology Center for Energy and Environment, who will give a presentation on their behalf. So Cristiano, please feel free to share your presentation.
Hello, and thanks, Eduardo, for inviting us here. Good morning to everyone. Okay, I will just share my screen and start with the presentation. Can you see the presentation?
Yes.
Okay, thank you. So thanks for introducing me as well. And I'm here as a representative of the leader of Green Nomad, the Living Lab. That is a green innovation Mediterranean living lab in the southeast of Spain. We are um, we are formed by different main partners. Here you can see Sebas, Fundación Cajamar, and IMIDA. And our goals in our living lab regard circular fertilizers, healthy soils, and low input and regenerative agriculture practices. And today we will focus, of course, on circular fertilizers. So just to give you a quick background of our living lab, it was funded in BioSOILution project, and now it's taking the actual shape in IcoShare project, where you can see the rest of the living labs that are funded on under this European project. We have Spain, Basque, and Swedish, Greek, and Italian living lab as well. But prior to BioSOILution, we were also participating in other circular economy European project that we will see later. That is Hoop project. So why do we need a living lab to foster the innovation on circular fertilizer? Well, the living lab actually are able to create a field test network, collaborating and work together directly with the voluntary farmers, and the business models are co-designed together with them during many co-creation events, of course. And thanks to the Living Lab, we are able to understand fertilizer application needs, as well as concern about these alternative circular fertilizers, as we want to call them, and also the real needs in the fertilization sector, having this feedback directly from the end users as the growers are. So the innovation through a living lab is more strategic. Why? Because in living labs we have available real life tests where we can face real needs from the growers. Thanks to a preliminary exploration during co-creation events and meeting involving many categories of stakeholders in these sectors. And thanks to the co-creation solution and market development, we could design the direction for the alternative fertilizer production. And thanks to the multiple technical expertise in a living lab, because the main partners we will see that involve like economists, circular experts, agronomists, and scientifics as well. So recommendation from innovation from our living lab, as I was mentioned, include a wide range of technical expertise among the operational structure, such as agronomists, environmental scientists, circular economy experts, that they will all contribute to the success of any alternative fertilizers production. Some key points to keep in mind are like avoiding stakeholder fatigue, of course, by clustering the different projects of the Living Lab under the same objectives. I mean, do not, let's say, boring stakeholders explain all the many different projects, but just explain them the different objectives under the same living lab. it's really important that during the events and the meeting, we deliver result and solution of the several products that we are developing. In this case, alternative fertilizer, to keep engaged the all stakeholders categories, and of course schedule at least two meetings per year where co-create and develop new experiments and service that we can offer to them. One of the most important tool is also the cascade funding, where stakeholders or even new partners can be involved to develop new project or to test new solution, such as alternative fertilizers, for sure, and also to promote the living lab growing. Now, focusing on circular fertilizer recommendation based on our point of view, it's really important that the circular fertilizer formulations that we are proposing, we have at least available 50, 60 kilograms minimum to test them in real field conditions, because one of the strength key of the Living Lab is that the demonstration are, as we said, at real life scale. I mean, not only in lab, because growers can see the result directly by themselves. And of course, they are not going to visit any lab. They prefer to go to the field. So yeah, and many other aspects to take into account is that formulations need to be co-created with them, with the stakeholders categories, of course. If we want to add biostimulants, if we want liquid or solid form, or even the nutrient content need to be specific for their needs. So this regarding the end product. Considering the feedstock, we need, of course, to pre-evaluate the availability and its purity, because then we will face regulatory requirement and barriers at any step of the innovation and co-creation process. So we need also to take into account also the availability and also the purity of the feedstock that we choose to use. So from FOOP, that briefly, it was a bioeconomy project that it ended 2 months ago, involving different cities and regions around Europe. We have Portugal with Oporto City, Italy, and other sites. One of the key was to reuse the biowaste for alternative fertilizer production and so uptaking. So the project was mainly focused on compost and biochar production from different feedstocks such as biowaste and green waste, compost refuse, and also green waste for biochar production. I just wanted to highlight that, as you see, compost from biowaste and from the compost from green waste are totally different in terms of legislation and requirement to be achieved. So no animal byproduct involved that make things pretty much easier to the production. So one of the first outputs after this project was, let's stop hindering biochar from biowaste, because the regulation nowadays need to be a little bit upgrade and giving established and clear requirement for endpoint criteria to use also biowaste in case of biochar production. and B, upgrade in terms of, for example, technical aspects such as the temperature for pyrolysis that are exceed significantly the ones set for other methods to achieve the end of waste status. So as well, the revision of industrial emission directive, because pyrolysis, it can be seen as a general industrial process when used for biochar production. So those are one of the main two of the main outputs that we saw during HOOP project. Of course, the end of waste status and quality assurance established criteria need to be specific for each of type of feedstock and clarify the end of way procedures. So, for example, here we have also the case in Oporto. That's why we suggest the revision of invasive alien species regulation, because they had issues with vegetal invasive alien species that was was to be used for biochar production, but as there are no specific regulation on use of invasive alien species, because use it for compost production is not allowed, because seeds can be spread among other sites and causing issues. But in case of biochar production through pyrolysis, these issues won't be necessary to be achieved. And then, of course, promote the implementation of product and process quality and assurance schemes in all member states to, of course, to support and promote the biowaste derived fertilizers, such as many other policies. So in general, in summary, revising key regulation and regulatory frameworks that we mentioned, and of course promoting innovation and investment by expanding funding also to public sector and ensuring that the UA taxonomy allows a little bit more flexibility for high performing and innovative technology that are not still listed explicitly. That's all from my side. I will leave the floor again to Eduardo.
Thank you. Thank you very much, Cristiano. Let's now move on to another project, which is Bean2Bean. Let's see if Dr. Henning Frege is available for us to share his presentation on biowaste management in Hamburg.
Yeah, thank you, Eduardo, and good morning, everybody. Let me get up my presentation. So there we are. No, that's not the right one. Excuse one. Yeah, this was Bean2Bean, but this was a cloud and not the presentation. So sorry about that. What is Bean2Bean? Eduardo already introduced this project. Bean2Bean is an EU co-funded project. We started in September 2023, and we will finalize the project in September 2026. So we are just in month number 20 or 2023 now. 20, no, not 23, 21. And we have already some interesting results, and I will try to present some of these very shortly in the next 10 minutes. First of all, what are we doing? we look at the complete value chain. This is most important. We start with a bio bin, or we start with consumers and waste producers, and we stop with the soil. We end with the soil, and we look at every step in between, especially in 3 living labs, to learn about general good solutions and to develop better solutions which can be used everywhere in the European Union, despite there are a lot of problems depending on the type of soil, depending on the culture of the nation, depending on the regulatory frame, and so on and so on. And the main target is the creation of tailored business models for the best performing solutions for composting, methanization, and the use of the products, especially of soil improvers on soil. Now, let me go a little bit short into the living labs. We have 3 living labs: Hamburg in Germany, Amsterdam in the Netherlands, and Egalio. This is a city in the metropolitan area of Athens. The 3 living labs are quite different, with one exception. This is a population density. Let me just run through the figures. Hamburg has nearly 2 million inhabitants, Amsterdam nearly 1 million inhabitants, and Egalio 65,000. In all 3 cities, there are a lot of students who are probably not included in this number. And in Amsterdam, especially in Amsterdam, a high number of tourists. What about the collection of bio-waste in Hamburg? Excuse me for just a moment. In Hamburg, about 74,000 tons of bio-waste were collected last year.
We don't see your presentation anymore, Henning.
Okay, sorry about this. Wait a minute. So here we go. In Hamburg, 74,000 tons of bio-waste were collected, plus about 20,000 tons of green waste separately about via recycling yards. In Amsterdam, about 5,000 tons. In Egalio, the introduction of the bio-bins just started last year in the commercial waste producers, and it's now in February it started for private households. So in Hamburg, the complete city and bio-waste is collected in the complete city, and they started about 30 years ago. In Amsterdam, the collection area is restricted to several suitable districts. There is no or very few collection in high-rise building areas, and in Egalio, I'm quite sure we are in pilot areas in the very moment. The collection method in Hamburg as well in Amsterdam focuses on door-to-door collection plus underground containers. And in Amsterdam, we have a lot of bring systems that are organized by special communities. Egalio is collecting its waste by containers on the curbside. This is a solution that will not work for bio-waste for a long time. And we are discussing with Egalio in the very moment what could be done. The processing in Hamburg is an own facility owned by Hamburg and owned by the Stadtreinigung Hamburg, digestion plus composting. The same in Amsterdam, but we have also a number of decentral processing units. And very important, the facilities around Amsterdam are not owned or shared by Amsterdam. These are they just deliver the bio-waste there. And in Egalio, there's a new, not in Egalio, but near Egalio, there's a new composting facility for the complete region of Attica. Hamburg sells the soil improvers from the processes to farmers and private households. Same in Amsterdam, if the quality is okay. And for Egalio, in the very moment, there is only some use in private households and in school grounds. It is very important to look at the regulatory frame for Hamburg, and it's quite clear that we have a twofold implementation. First, from the European level to the national level, and then from the national level to the city level. The colleague from the ECN has already reported about the European legislation. I just mention here the Waste Framework Directive with the recycling target and the separation of biowaste, which is enforced since 2 years or one little bit more, and the polluter pays principle. And she also described the fertilizer product regulation, most important for the quality assurance of composts and organic fertilizers. At the national level in Germany, we have a separate collection, compulsory separate collection since 2015 for biowaste. And we have a special regulation for quality assurance for products made from biowaste. And this is not very often. This is a special regulation in Germany. I don't know if there are other European countries have similar regulations. We have limit values also for the input of biological processing, especially a control level for plastics that is enforced since about 6 weeks now. You should see 1% is a very low level. The city of Hamburg has, as all cities in Germany, is responsible for their own charging policy and for special regulations concerning the size of bins and so on and so on. They have a so-called bio-waste ordinance. That means that the citizens must use the bio-bins provided by the cities. Exceptions are possible, for instance, in case of home composting. And the waste disposal fees are very interesting. They have a differentiated charging system depending on the volume of waste. And within this charging system, there are remarkable benefits for bio-waste separation. That means that the bio-waste bin of a certain bio-waste bin costs about not more than 20 to 25% compared to the same or to a bin with the same volume for residual waste. If you like, you can interpret these regulations on all levels with 3 questions. What are they enforcing? How are they enforcing quantity? How are they enforcing the quality of the output? And how are they enforcing the quality of the input? I think this is very interesting for our discussion after the presentations. And I think that output and input quality regulations depend on each other. But from my experience, I think that input parameters and input quality indicators are very important for biowaste, in contrary to other waste fractions where I have not so many problems with the quality and especially with the pre-sorting in the facilities. What is the current status in Hamburg? As I already told you, they collected about 74,000 tons bio-waste. The next target for 2030 is to collect 107,000 tons of organic waste, plus about 20,000 tons of green waste. The goal for the bio-waste quality is, according to the German law, but also traditional for Hamburg, less than 3% contaminations in future. The Pittsburgh Biowaste facility is owned and operated by Stadtreinigung Hamburg. This is a company that is owned, which is owned by Hamburg, has a capacity of 60,000 tons biowaste per year in the very moment. The capacity shall be enhanced up to 90,000 tons per year. and this facility is now under construction, so the normal operations are going on. That's a difficult task, I suppose. What about the quality of the products? One of the products, quite clear, is methane. This is corresponds to the RED 3 directive, RED 3 regulation. And until now, the quality of compost covers and meets the German quality mark and can also be used for organic farming. This is the highest level. I heard from Hamburg that they try to get also the CE mark, but this is a little bit difficult. But there will be, I think that they will be successful with this task at the end of the year. What is Hamburg doing and with regard to communication and awareness raising? In general, they have a wonderful proverb: waste separation pays off. And it pays off with regard to climate, as we know, and it pays off with regard to resources, to soil, but also to charges. This is very important also for the citizens. Convenience is key. Hamburg provides an app for waste management and free paper bags free of charge for the bio-waste sorting in the kitchens. And these paper bags are very strong, so there is no odor and no liquids getting out. They have a number of activities to inform tenants of large housing complexes in coordination with the owners. This is very important because Hamburg is also a densely populated city. They offer waste training for children, for pupils, school pupils, and so on. And there is quite clear also control of the biobins from time to time. And in case of spoiled biobins, the waste users get a yellow card. And if there is if the problems do not stop, they receive a red card. This means extra fees for tipping as residual waste. We had from our project 3 more recommendations for Hamburg. First, activate interested citizens as ambassadors of compost. This is something that works in other cities very well. Integrate soil health in your communication strategy. This is a gap that can be filled. And engage organic farmers as advocates for sustainable organic waste utilization. They are the best ambassadors, I think so. Last slide concerning the value chain. Hamburg controls the complete value chain from the collection of green waste and the collection of bio waste, the removal of impurities in the facility, the composting process, the digesting process, the removal of impurities after the composting process, sieving, and then production of customized compost. This is very important. Amsterdam is not in a position to control this complete value chain. And that means that you have no idea about the needs of the farmers. You have no direct contact to the farmers. And this direct contact is very, very useful, not only for the composting facility, but back in the value chain to the collectors. Yeah, the collectors, the workers in Hamburg know exactly, okay, the bio-waste which is collected in my truck is going to the composting facility, and then it's a soil improver. And I think this thinking along the value chain is very important. We have a similar problem in Egalio. Egalio started the collection, as I already said, but they deliver the bio-waste at a composting facility, and they have no connections with the composting facility. This is just a business. And this is not enough a value chain should not be interrupted. Very important point. Yes, I think this, quality matters. Again, very important, the contaminations in the biowaste can only partially be removed, and that's the reason why we are so, that we should be cooperative along the way, along the chain. Yeah, that was my presentation. I have a number of questions and a number of conclusions, but I leave it to the discussion, and then we have some more time there. Thank you.
Thank you very much, Henning, for presenting this complex framework of regulations. And time now for our last project, FENIX. And we have with us Concetta Di Paolo, who is a regulatory expert at Eurofins. Please, Concetta, you can...
Hello, good morning. Thank
Hello.
you for joining this event this morning, and I'm very happy to have the opportunity to share our approach. So I'm going to share the presentation. Is it okay?
Yes.
Okay. So as you said, Eduardo, I'm going to speak this morning about just the regulatory aspect of the FENIX project, because also FENIX project is a massive project. It's going to be articulated into 4 years. We are at the second year. And today I keep this very, very simple presentation just on the application, practical application of the regulatory strategy to see how it works in practice to let's say to convert like a waste materials into a soil improver or into a fertilizer. Of course, a FENIX project is an EU-funded project, and here is the checkpoints that I'm going to present this morning. So I will start with some definition and some implication at harmonized level, and I will then analyze a little bit the framing, the strategy that we applied in FENIX, and we will present some takeaways, conclusions. So as also Aline presented the definition of biowaste we have from the Directive 98/2009. So biowaste basically are regarded as biodegradable garden and park waste, and also food waste from kitchen, from household, from restaurant, and also sometimes from food processing plant, just for the residues which are comparable to the same residues. As also Professor Henning presented, we have this directive, but basically waste are regulated different. This directive has been implemented differently at national level. So from one member state to another member state, this waste material is subjected to different requirements, especially for what it concerns, for instance, the storage, the transportation of these materials, and also the end of waste status. But when it comes to FPR, which is this fertilizing product regulation, which is an harmonized regulation, the regulation 1009/2019, when these biowaste, these materials are contained into a formulation which achieve the conformity, so it passed the conformity assessment, this material is regarded as fertilizing product, as start to be subjected only to the FPR requirements, and stops to be subjected subjected to the waste regulation. So the FPR, it is an harmonized regulation and overall regulation. So this is a big opportunity for the recovery of this kind of materials. In this other slide, I just presented like a visual images, a visual approach. Here in this picture, we have like the pyrolyzer, which is in the site of Marmagne, because the main techniques that we are using in FENIX project are pyrolysis and anaerobic digestion. For the pyrolysis, the feedstocks are basically of vegetal origin. So we are using green residues and also woody residues or composting residues of vegetal origin. You see here the images, while for the anaerobic digestion, we use different kind of sources. So what we did basically as a regulatory approach was to sort out these feedstock, these sources, and to try to frame this kind of materials under the fertilizing product regulation and to fit them under the component material categories. So for the biochar, basically we have this vegetal woody residues, while for the anaerobic digestion we have more products, not only digested derived from energy crops, but also from other sources and also from animal byproducts. So the requirements related to these categories are quite different. So I will share just the approach. So especially for the digestate, we started from the list of materials conveyed to the plant. We started basically from the sorting these materials from the European waste codes for the identification of this kind of materials, and based on the identification of this material from the European waste codes, we framed under a CMC, and we checked at the end the compliance to the requirements at CMC level. And after that, we consider also the requirements at product function category. So basically, the evaluation should be made at two different levels. The first level is at source, the evaluation of the sources, and the second level of requirement is related to the product function categories. So basically, for instance, for biochar, the main requirement that you have is to check the quantity of polycyclic aromatic hydrocarbons. There are harmonized methods. I didn't present any tables with the methods, but under FPR we have harmonized methods for the determination of all these parameters. Basically, we need to check the polycyclic aromatic hydrocarbons, the production, for instance, of other organic compounds that can be problematic under health perspective. So, for instance, dioxin, and also we need to check the ratio between hydrogen and organic carbon. And of course, another important requirement for at component material category level is related to the requirement related to REACH, because FPR is an overall regulation. Its main aim is based to ensure a high level of respect for the environment, for the human health, also for the plant health. So this finished product at the end do not need to be also phytotoxic. So to ensure this high level of safety, there are some requirements related to safety itself and REACH. In particular, when a material follows under REACH, it's ensured that you need to provide the exposure scenario of those materials to the different environmental compartment. So it is a high level of protection, let's say, under this perspective. Also for digestate, we evaluated the importance of the regulatory framing is to check the obligation that you have, the obligation that are related to the use of those material. So for instance, if you are feeding your anaerobic digestion plant with animal byproduct material, you need to ensure some safety criteria because you need to ensure that this material has reached the end point of the manufacturing process, and FPR has been implemented in order to foresee this kind of safety criteria for this kind of material. And also another important requirement when it comes to anaerobic digestion is the presence of macroscopic impurities, especially glass, metal, or plastic. We have a stringent restriction for the presence of this kind of impurities, and also the direction is to restrict much more this limit. While at product function category, the second evaluation, when you check the material and when all the material which you are using to feed is compliant to the CMC, the second step is to evaluate the compliance in terms of product function category. So whether if it is PFC 1A, so an organic fertilizer product, or if it is a soil improver, you have some requirements to meet. First of all, you have to check for organic metals. You have to provide some analysis report related to the presence of heavy metals. I didn't report any table, but we have harmonized methods for the analysis of heavy metals, and we have threshold limits for the presence of these contaminants, and also for pathogens, because it is going to be an organic product at the end. So we will need to check for the presence of Salmonella, E. coli, all pathogens that can be harmful to human health. And of course, if we want to frame the product as organic fertilizer, we need to also check for the granted analysis, so for the primary and eventually secondary macronutrients that we are going to provide. So I keep it very, very simple, just to have an idea about the steps ahead for the evaluation. And in conclusion, as basic comments, I would say, as recommendation, I would say that I would suggest to always evaluate your feedstocks in all the steps. So from the disposal to the reuse, check whether any restrictions applies to the material that you are using in your technology. Characterize very well the output of your process. So define the level of purity, define possible contaminants, and also have a clear idea of the target market, of the function of the finished product that you want to achieve at the end, the purpose of your finished product, the users, and be aware of the requirements, and check periodically your product to be sure that the properties are maintained constant along the time, and basically having a good knowledge, a good know-how about the product and the way of action. So yeah, basically these were the main point that I wanted to bring here today. And if you would like to get in touch, here I put my contact details, and also if you want to know more about the FENIX project, here you have all the links to the FENIX project.
Thank you, Concetta, and thanks to all the speakers who give us a very complete overview of the work carried out in the 3 projects, as well of the policy and regulatory aspects connected to our topic, bio-waste management and bio-waste valorization. We have now around 15 minutes, let's say, of interactive session between today's speakers. So one of you talking to the other speakers presenting today can make their own questions, and another one can reply according to their experience. So is there anyone who wants to start with a question?
Otherwise, I can also, yeah.
Yeah, of course.
We
Laura.
have some questions that the speakers can reply, and even people in the audience, if you have any ideas that you'd like to share, you are also welcome to do so. So just to break the ice, I will share my screen with our first question, and then we'll see how things keep going. There you go. Can you see the screen?
Yes, but we don't see the questions.
Yeah.
Okay.
All right. First question, how can we address the discriminatory aspects of end-of-waste regulation?
Maybe I can start to reply to this, and maybe Concetta can also complement, because it was mentioned several times during our presentations. So, and as I also already said, so the end of waste criteria, end of waste under the fertilizing products regulation. So first, it's not mandatory. So the plant operators, they will have to choose based on the cost and how competitive cost effective it will be for them to comply with it. And also there are the end of waste, basically it can be difficult to comply with. So for us, for the composting process, so there are strict requirements linked to animal byproducts, as it was already mentioned. So because animal byproducts, so it's meat basically, and so you can find pathogens, and so there are strict requirements to ensure that the pathogens are eliminated, but basically these requirements are not are not applicable to the composting process, because requirements are too high in terms of temperature, for example, that they set a temperature that we cannot reach. So what happens is that member states, they develop their own criteria with alternative requirements, which also creates fragmentation, of course. What we recommend as ECN, it would be to simplify and harmonize the requirements so that we are able to put the CE mark on our products, because if we don't comply, we cannot put the CE mark in the end. And it would also be good to recognize this national validated requirements, alternative requirements, because so they are validated under national law, and they are even allowed under the fertilizing products regulation. The fertilizing products regulation allows member states to set alternative parameters for composting processes, for example. So yeah, it's also something that could be done.
Great, thank you.
Okay.
Anyone else wants to add something on this?
It's
Yeah, just to
oh, sorry, excuse me. Ladies first.
yeah, just to complement that FPR, it is not mandatory. It is a voluntary regulation. So let's say the manufacturer, the producer can decide if comply to the FPR or if go under the national way. The important point is that, for instance, if you are producing, for instance, a compost or a digestate, and you want to sell this material, for instance, to a formulator which is outside your border. One possibility is that your material is recognized as past the conformity assessment as the CE mark, and in this case the transportation is quite easier. But of course, at the very beginning, you need to comply to the requirements. Otherwise, you are subjected to the national legislation in terms of transportation and storage of this material, which is regarded as waste. And this regulation and this requirement can be different from one member state to another. So even if we have a material which, for instance, in our own country has reached the end of waste status, and we want to transport this material outside the border, we need to ensure that we comply with the national regulation.
Yeah, just one more remark. I agree with the speakers, with the speakers before. One problem comes from the European hygiene regulation, because it is difficult to fulfill the requirements 70 degrees Celsius over 1 hour exactly, and certain sieving on 12 millimeters and so on. Just from a composting process, this is possible in an anaerobic digestion. And okay, this must be solved, and I'm happy that ECN and others are working on this task.
Okay, I think, Laura, you can share the next question.
Yeah, as you can see, the second question we decided to formulate is what are the key challenges in boosting the market uptake of alternative fertilizers? Maybe some of the speakers can talk about their experiences in their living labs and in their activities.
Yeah, I can start. Well, quality is a key. And second, farmers must be sure that the quality is okay, was today, yesterday, and is okay tomorrow. In my neighborhood, there is a farmer, an organic farmer, and I asked him, would you use compost from biowaste? He said, never. I have seen what happened in my neighbors' fields. There was too many plastics in it. That was an experience from about 20 years ago, but they today know about these problems 10 or 20 years ago. And therefore it is most important to have high quality bio-waste, to get high quality compost and digestate from this resource. And then it is really, again, a challenge to convince the farmers to take this. As already mentioned in the discussion about the end of waste regulation for compost, the national quality assurance associations and the national quality assurance regulations are very important besides the EU regulation, because a farmer in Greece or a farmer in Germany, I think they believe more in the Greek or German quality marks than on a CE mark. So a CE mark is very important and proves a lot of goodies for the clients, but the quality associations are very important, and we will see this in our project as well. We are just starting a quality test between a number of laboratories to check the different approaches to quality in our living labs. So these are my both key challenges, and back again to the bio-waste, to the quality of bio-waste. As I already mentioned, this is most important. It is necessary to start with detached and semi-detached houses, with bins where the users are known, and then go to the more densely populated areas, because quality is decreasing in this moment, and we need the experience going step by step into ever more densely populated areas. Otherwise, we will not have success.
Cristiano, you also raised the hand.
Yeah, thanks. I'm totally, of course, with Professor Animi about it. The quality, I will just add a few things that are a little bit more technical regarding the end product. Of course, the nutrient content is really important for the farmers from our experience, because, like agriculture today is really technical, so they need really specific formulation in terms of nutrient content, and also the radio, let's say, for nutrient and volume or kilograms of the end products. Today, we know that if we want to give, I don't know, let's say an example, 60 unit of nitrogen, if you use traditional or chemical fertilizers, we just need a really small pack of product. But if we want to use compost, biochar, we will use, of course, a higher volume or higher weight of end products. So those are also aspects to consider at the process when we want to develop new alternative fertilizers, I would say. Thank you.
Okay, I think we have one more question. And also, just to save time, Concetta, I think you have a question. There is a question for you in the Q&A box, so you can maybe start replying to it in the box while we continue with our session.
Yes, there was also a couple of questions in the chat in case you can have a look.
Yeah, okay.
There are 2 questions more to come, but we can at any time change depending on the priority of the questions, also in the chat if necessary. So the third question is, what makes it challenging to engage farmers in adopting circular fertilizers? Go ahead, Cristiano.
Okay, thanks, Laura. Well, also from our experience, to, of course, to gain farmers' trust first, and a lot of meetings to share the knowledge about the new typology of fertilizers have to be achieved, because most of the farmers don't really know or don't have the technical knowledge of this typology of products. So they need to know better, to see experimental field where these fertilizers are tested, the results that they produce. They really need to see with their own eyes that they are working, they are worth the cost effective. So I would say that from our experience.
Yeah, indeed, they need to be involved much earlier than they have to use it to see how the tests are running and so on. Okay, anyone else, or we can move maybe to the last question?
Yes.
The last question is, how can we set up and effectively control the circular fertilizer value chain? Yeah, Henning, please.
Yeah, I can try to answer. There's also an interesting question by George Pekulidis here in the chat, antibiotics and so on. But this can be probably be better answered by someone other than I'm not. I will start with your question. How can we set up and effectively control circular value chain? Yeah, I think it as I mentioned the situation in Hamburg, this is really an nearly optimal situation. So the charging policy, the collection work, the composting, digestion, and the marketing of the compost is in one hand or in one big company or in some companies that are shared by the city of Hamburg. This will not be the case everywhere, and it is also not really necessary from my point of view. But it is necessary to cooperate in the value chain. That means that, for instance, the company or the city which is responsible for the collection of biowaste is in touch regularly, let me say, with a commission or a working group, with the facilities, with the processing, with the people who are responsible for the processing of the biowaste, and with a marketing company. So who is marketing this? And the marketing company has this big interest in to be in touch with their clients, and this chain should not be interrupted. This is, from my point of view, the minimum condition to get a good control of the circular fertilizer value chain. And it must be a company. This has already been mentioned by the colleague from Eurofins, by a good quality assurance work, quality control. This is mostly, this is not only looking at the fertilizer, but also on the bio-waste input into the composting facilities. It's a very important point for control. I can answer George's question as far as I can, but I don't know if there are other colleagues who can add something. First question is antibiotics affects biogas production. This depends, as always, on the concentration. But this is a question which you should ask the people who are responsible for the biogas production. I have heard about problems with that, not from biowaste digestion, but from the digestion in in the agriculture, which a feeding material which was nearly completely full of antibiotics from livestock. this is really a problem, not from bio-waste from private households. Second question, Digestate from anaerobic digestion. Yeah, this is a matter of I think it is soil. It is safe when we had this 70 degrees for some days, no problem normally, but it depends on the soil. If there is a soil that is full of nitrogen, like it is in the surroundings of Amsterdam, then you have no chance for a product from a digestate. And this is in the Netherlands. This is not allowed to use digestate directly on the fields because of the high nitrogen contamination of these soils. This is quite another thing in quite another situation in Greece or in other nations in Southern Europe. So it's a matter of the region and also area, I think so.
Yeah, maybe someone else can add something to this from the other speakers. Is there any other question that I'm missing? I don't think so. Okay,
No, I
great.
think it's okay.
Perfect. I think that's all, and we can close this. Oh, Cristiano, okay, please. Sure, Cristiano.
Yeah, thank you,
I
Eduardo.
know.
If you just will let me, we have a quick survey about alternative fertilizers.
Of course.
From the FertiTech project, actually. It's a sister project of Verticover. If you... Should I already share my
Yeah, you
screen?
can share your slide. Yeah.
Okay, thank you. We will really appreciate your help. So I don't know if you can already see the slide. So the QR code is here on the right side for me, and it's a 10-minute survey about alternative fertilizer under the European project FertiTech. So if you would like to spend 10 minutes and contribute to give your opinion, knowledge, and information regarding alternative fertilizers, we will appreciate it.
Great. You have the QR there, so you can take the questionnaire anytime.
Okay.
And yeah, you can also maybe send the direct link in the chat.
Okay, sure. I will copy and paste if I... Okay.
Okay, perfect. I think that's all. And thank you very much to all the speakers today and to all the attendees that follow all the presentations. And hope you enjoyed the session. And as I said at the beginning, the registration, the recording of this webinar will be available on YouTube. And you will find the link very soon on the project's website and on our LinkedIn pages. So I think on the chat, the link of some projects already have been shared, but I will share also the link on the other two projects. So this is FENIX. And this is bioSOILutions. Perfect. So thank you very much for joining and enjoy the rest of your day.
Eduardo,